I copied that. Time at time t is modeled by a strictly increasing, that was important, twice differentiable function, W, where W of t is measured in degrees Fahrenheit and t is measured in minutes at time t equals 0. The temperature of the water is 55. There's my initial condition. I'm probably going to have to use that again somewhere. The water is heated for 30 minutes beginning at time t equals 0. Values of WT at selected times for the first 20 minutes are given in the table above. Always, always, always read through whatever's given to you because there is probably some embedded information in there that you need. And it's always helpful to read through before you start. All right, so then part A says, use the data in the table to estimate. And notice it says estimate because we can't get an exact derivative here, but W prime of 12, show the computations. Oh no, what happened to it? It was up there, wasn't it? What happened to it? Show the computations that lead to your answer and using correct units, interpret the meaning of your answer in context of the problem. I think most of you got the derivative. You got the rate. So, of course, and let me find the scoring guide here. So to find this, I don't have a 12, so I estimate with the two closest values, one above and one below, right? So I did W of 15 minus W of 9 over 15 minus 9. So that's the Y over the X, just your basic AROC. When you do this, and again, this was a calculator problem, you got approximately 1.0167 degrees per minute. That was 1 point for your estimate, and you didn't have to have the units on that one because you had to explain. I put the units on mine because that's just going to have it to be in. But yes, approximately 1.0167 degrees per minute. All right, so then it said to interpret your answer in context of the problem. Now remember, this is an instantaneous, right? Because it's at 12 seconds. So at time 12 seconds, or after 12 seconds, or at, not after, but at 12 seconds, because it's exactly at that point. At 12 seconds, the water temp, or the temp, is increasing because it's positive at a rate of 1.0167 degrees per minute. Say again? Yes, it's minutes per second, yes. Say it again, Allison? Okay, yeah. Does that make sense? 1 point for the interpretation, 1 point for the estimate. Part B, use the data in the table to evaluate the integral from 0 to 20. I was amazed at how little I used my calculator on here for this was in a calculator question. The integral from 0 to 20 of derivative. Using correct units, interpret the meaning. So if I'm doing the integral of the derivative, it's area under the curve, that's right. But what I'm really doing is, that's right, from 0 to 20. Both of those are values on your table. So this is W of 20. This is just testing your knowledge of fundamental theorem. All it's doing minus W of 0. So I get 71 minus 55, which is 16 degrees. Now, the hard part of this one to me, that was 1 point, by the way, for the value. The hard part of this one for me was the interpretation. I struggled a little with this interpretation. So what does that mean? If you do the area under the derivative, what does that mean? It's the total increase. That's exactly right. It says that over the first 20 minutes, from 0 to 20 seconds. Thank you. The temp increased a total of 16 degrees. You get 1 point for the value and 1 point for interpretation with units. Did you have both those? Yeah. You have to say, they said their interpretation with units said the water has warmed by 16 degrees over the interval from t equals 0 to t equals 20 minutes. All right. And this FRQ was, this whole section I felt like was real big on interpretation, more so than usual. But they really wanted a lot of stuff in words here, which is a struggle sometimes. All right. Part C. Yeah. Okay, point C says between 0 and 20, the average temperature of water in the tub is 1 over 20 times. I'm going to have to pick up the pace here. Use a left Riemann sum with 4 subintervals indicated by the table to find the average over the 20 minutes. Is it an underestimate or an overestimate? Generate and explain your reasoning. So back to my table here. So if your function, and this is what you had to say with that reasoning. Because the function is strictly increasing, that was in that very first sentence there, okay? Because the function is strictly increasing, a left Riemann sum will be an underestimate. If you think about if your function is decreasing constantly, right? And I do a left Riemann sum, I'm missing area under the curve. Some of you drew a picture like that to indicate such, and that was great. I had a little sketch on the side of mine as well to show. Oh, that's not decreasing. That's your function is strictly increasing. Left Riemann sum. There we go. I have that on the side of mine to show, but then I put it in words, okay? So because it's increasing, that's why. All right, so that's the explanation. That's, of course, a point. And then you got a point for setting up the Riemann sum correctly. So let's look at these. You've got, I'm not going to rewrite these numbers because you have them on your paper. But remember, Riemann sum, and I'm going to just go ahead and do 1 over 20. That's just my average value that was given. Now I'm using the Riemann sum to estimate this portion. So the width varies each time. From 0 to 4 would be a width of 4. And I take the left value, so it's 55. Plus, now I go to the next rectangle. From 4 to 9 is 5. Left sum would be 57.1. Plus, and then from 9 to 15 is 6, using the left value. And then 15 to 20 is 5, use the left value. You got a point for setting that up that way, knowing what the left Riemann sum was and using it. That's 1 point. And then the approximation, which was done with your calculator, 60.79. Degrees. They didn't ask for the units, but it was degrees. Do you remember now? I thought I was supposed to subtract the bottom. What do you do? I'll be right back. Okay, let me put the table on here. 0, 4, 9, 15, and 20. And we have these values: 55.0, 57.1, 61.8, 67.9, and 71.0. So I'm making these rectangles, right? Here's one rectangle. So the width is, yes, that's your x value here. That's how far it spans. So there's one rectangle. Here's the next rectangle. Here's the next rectangle. I think so too, I just looked at that. And here's the last one. So my width here would be 4, my width here would be 5, my width here would be 6, my width here was, and then you just take the left value each time. A rectangle is length times width, so this is your length. But it doesn't go from one to the next because it's left Riemann sum. I just take this value with this, and I don't use that last one because those are those rectangles coming up like this. I'm using this value. This would be 0.55. This would be, which would be the next one up. So if this was a right ram, that's right. Everything would be the same, but the difference is here. This would be 57. This will be 61. This will be 67. It shifts, and then you'd use that last one. For MRAM, you'd have to average them together. Have to add and divide by 2. Okay. So 1 for the left Riemann sum, 1 for the approximation, and 1 for your reasoning. Bless you. So part B was strictly calculator. You had to look here at the initial condition, or at the restriction here from 20 to 25. The function said that's past my table, right? That goes out 5 more seconds than my table. So it wants to know if if the derivative here. So W of 25 is going to go from 20 to 25 on this one, right? You guys, I wrote this on all yours. At one point, they were deducting. They were not giving you your answer point if you did it. But if you do an integral, make sure you follow with that dt, dx, d, whatever it is, because I don't want you to lose your point because you don't put it.
Wait, what if I did 0.25? I wrote that. Was it 19.077? And then add that.
It was 2.043 to 71. Because, well, the reason is it told you that this derivative only represented the time from 20 to 25. So if you went from 0 to 25, that function doesn't represent it on the 0 to 20. So on the table, the temperature ends up at 71 degrees. Well, because so it's increasing. So you do this to find out how many degrees it's increased. What's that total? Remember, that's what it gave us. That's how we explained it. Right. How much more did it increase? And we add that to the 71. This was 1 point for the integral itself and then 1 point for the answer. So if you had the integral but didn't put the plus 71 on there, I gave you a point. That's one of those things they probably sit around those big round tables and talk about if they should give you the point or not. All right, so that was 1. Do what? Yes, yes. What takes them so long to grade them? All right, number 2, rotation. This goes out to 2, 3, 4, 5. 1, 2, 3, 4, 5. It looks something like that. The first thing I did was label what everything was in the picture, and I went up to that in the top and I labeled, and I said, okay, this is the natural log of x, And I knew that because this was the straight line. So this was y equals log x. This one was 5 minus x equals y. I went ahead and found this point of intersection on my calculator because I knew that that was going to be something I was going to need. And I did not round it off just yet because I just wanted to make sure I had it written somewhere where I could see that I could go back and reference. So this is what I used to reference. This is how I attacked this problem initially. Find the area of R. So whenever I saw this, I went, okay, well, area is top curve minus bottom curve, but I don't have a top curve and a bottom curve. I have with respect to Y. So you could have done this two ways. I think you split it up and kept it with respect to X. So if you did that, you had to do two different integrals. Okay, if you wanted to keep it with respect to X, you had to do two integrals. So you would go from 1 to 3.69344, and if you want to, and this is something that they do frequently, if you want to stay in the beginning, how did they? If you want to, like, if you want to let A equal, they said let AB equal 3.69344, 1.30655. If this is something that you like because you don't want to keep writing those numbers, and then here I would say from 1 to A because I've already defined what A is, that's okay. You can do that. Okay, I don't do that because I'm scared I'm going to lose what I'm doing. But this would just be the log of X dx. Don't forget that dx. You don't have to subtract it from anything because I'm doing just the area down to the x-axis. And then the next one would be from, of course, 3.69344 over to 5, and that would be for 5 minus x dx. Okay, and it's a calculated problem, so from there you could just say that the answer was approximately 2.9858. Now the other way you could do is with respect to y. And this is the way I did it, but of course, if you are more comfortable with respect to x, by all means do that. You just had to make sure that you split up that integral. I went through and said, well, e to the y is x, and x equals 5 minus y. I did. Well, for me, it was easier that way because it was easier for me to say that the area was the integral from 0 to 1.3065586 of, and then I did right minus left. So I did 5 minus y minus e to the y. Because it's with respect to y here. I just went from here to here. If you, because for the x, there wasn't a top curve minus a bottom curve. So I had to split it up. So either way you did it was perfectly fine. You got 1 point for the integrand. You got 1 point for the limits. So if you did it with respect to x and you knew that you were using from 0 to this and this, that, you got a point for that. I'm telling you, always just write something. They give the randomest points. I'm telling you. Don't ever round initially in the problem on a calculator problem. Because the only answers they would take for the answers, 2.986 or 2.985. That was it. So 1 point for the integrand, 1 point for the limits, and 1 point for the answer. All right, flip over to part B. Where's I not getting through all these? Yeah. On your calculator? All right, so which one? You talking about the Y one? This one?
Yes, I got 2.13 numbers. I got the second one.
Okay, did you put 5 minus x in your? I would put.
I solved it. I went ahead and did all my.
That's why you're having trouble. Use your calculator. These are made to use your calculator. So I'd put y1 in, I'd put log x for y1, I'd put 5 minus x for log 2. Yeah. Use x, yes. And that's why I said it was easier for me. Now, if you couldn't do that, it might get confusing. But since this was a calculator problem, it was a really easy one. It was time saving for me to do it with respect to x. They were easy for solving. You good, Noah? Okay. All right, part B. Region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Right, but do not, I love the right, but do not evaluate. An expression involving one or more integrals that gives you the volume of the solid. So, here you did have to know where the split up happened. So I'm doing cross sections that run from here to here, and it says that that is the base of the square. Well, how do you find the area of a square? And what's the S? It's, well, here it's log x, and here it's 5 minus x. So I'm going to do two different, and you square it because it's area. That's exactly right. So I'm going to do two different integrals. I'm going to go from 1 to 3.69344, and I'm going to do log x squared dx, don't forget the dx, and to that I'm going to add, and then I'm going to come over here and do from 3.693. I'm really surprised they gave you 3 whole points on this one. Dx. That you had to split it up. You should not have. You got, so for this one, you got 2 points for having the integrands. This one said 2 points for the integrands and 1 for the expression of the total volume, which to me was the same thing. I don't know. Let me look because I can't remember. Oh, I don't know. All right, let me do part C, and then I'll give you a little break in between. The horizontal line y equals k divides the region into 2 regions of equal area. This one was hard to me. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. This is what I set up wrong initially. I didn't set it up the same way that they did, but so what this is saying is it's wanting you, I set it up as you have to do it with respect to y here because it's a horizontal line. You have no choice. So from 0 up to k, right? From 0 to k of, again, this 5 minus y minus e to the y. Yes, because it's a horizontal line, not a vertical line. There's no other way to get around this. Yep.
So why is it?
So this is not the whole thing though, huh? Because the horizontal line y equals k divides it. So because that's a horizontal line, I have to do it with respect to x. I have to go from bottom up. I can't go left to right like doing x because it's a horizontal line.
So you have to change your first two.
With respect to, right, yes. Okay, so when I set this up, I said 0 to k, I said this equals, and then I did from k to 1.3065. But what they wanted you to do is say that it equals 1/2 of the area from 0 to 1.365586 of that same function. I still argue that my way would have been acceptable and okay, but I'll give you the way they did it. It said K is a horizontal line that divides it into two equal parts. You could have also written this equals 1/2 of, since you already found that total area, you didn't have to rewrite all that. You could have just written that it equals. Because if you go from 0 to K, if that divides it in half, if you go from 0 to K, that should give you half of the total area.
It was not like the other one that we did.
No.
Because we did another one on our effort practice.
That was a vertical line,
Yeah.
which you have to do with respect to X. This was a horizontal line. I think that asked us to evaluate and find an exact value. This one just asked us to set it up right.
Yeah.
Yeah.
Okay, that's
Yeah.
all.
Yeah.
So this, so I'm looking at the graph
Mhm.
as I'm reading it. So if it's saying from 0, right, 0 to this K
Right.
equals half of the whole thing.
Of the entire thing. That's right.
Okay, because we're going from 0.
Because it said K divided it in half. Right. All right. So that was 1 point for the integrand, 1 point for the limits, and 1 for the whole equation. So you set it equal to 1/2 of the area. Each one was worth 3. What? All right, I'm gonna have to speed up, guys. We're running out of time. It took an hour on the first two. It's supposed to be 30 minutes. I thought the non-calculator was harder than the calculator.
Yes.
I did. Let f be the continuous function defined on -4 to 3 whose graph consisting of 3 lines. This was another one where it says this is the graph of f, but it says g of x equals the integral from 1 to x of f of t. So what are you looking at? If this is the graph of f, then you are looking at, and I write this every time. I wrote it under part A. I said that means that f of x equals the derivative of x. That means I am looking at the derivative graph. And that is imperative that you understand what it is you're seeing, okay? So the first one was straightforward, and it was plug and chug. Find g of 2, find g of -2. Well, this tells me then that means I'm finding the integral of f from 1 to 2 and from 1 to -2. Now, here's the problem. This one's easy from 1 to 2. I look on the graph, I find the area under the shape. Okay? Negatives count here because it didn't ask for area, it asked for the values. So just the integral itself. So from 1 to 2, if you look on your graph, I'm this little teeny triangle right here, right? It's got a width, a length, a base of 1 and a height of 1/2. Well, it's going to be negative, and I just made it negative in the end because it's under the x-axis. 1/2 times 1/2 times 1, and because it's under it is, so it's -1/4. That was a point. The next one was a little bit harder because it went from 1 to -2. So you had to remember that to switch that around, it's negative get a sign mess up there. If you switch the bounds, you negate the sign out front. So now I'm looking from -2 to 1, -2 to 1. So I've got a piece of a triangle there, right? And so here's what I did. I said negative, and then I started looking. That piece of a triangle has a height of 3, a base across of 1. So I have 1/2, 1 times 3. That's above the x-axis, so I keep it positive. And then you've got this semicircle, okay? So a whole circle is pi r squared, so a semicircle would be 1/2 pi. All I need is the radius here, and the radius of that circle is, anybody? 1. Radius across on that circle, it's 1. So, go ahead. Yes. So now you're absolutely right. I did. So you subtract it because it's below the x-axis. Don't forget this negative, this out front. So I really have 3/2 minus pi over 2, which is really pi over 2 minus 3/2 when I take into account the negative in front. That was a point. So that was just area under the curve. Part B. For g prime of -3 and the second derivative at -3, find the value or state that it does not exist. Here's where it was important that you understood the graph that you were looking at. The graph that I'm looking at is g prime of x. So for g prime of -3, what I'm really finding is f of -3. And if I look on the graph, what is f of -3? 2. That's a point. Okay. These were the first half of A and then B, I thought were kind of giving points. The second derivative at -3. So now if I'm looking at the derivative and I want the second derivative, you're looking at the slope of the line, and hopefully at -3 that's a line. Go to -3. It is a line. I've got 2 points. What's the slope from -4,1 to -2,3? It's 1. You did not have to do justification, anything like that. I mean, it's 1. So that was a point. Part C. Now we start getting harder. Find the x-coordinate of each point of the graph where G has a horizontal tangent. Whenever I read this, my stomach dropped and I went, oh my gosh, I have no idea. I'm so confused with functions and derivatives and everything else. So guess what I did? I did a sign chart. Horizontal tangents I know happen where? When the derivative equals 0. So I know that the derivative here is the graph of f, so that's what I'm looking at. So, and I literally do all this because I have to think through what, okay, so at -4 is not a 0, but those are my endpoints here, so I just put those on there. So remember, I don't go past there, but it looks like -1 and 1. And then I look to see what exactly is the graph doing at these points. Is it positive or is it negative? That's all I need to know. I don't need to know increasing, decreasing. I just need to know positive or negative. And if you look at the graph, I'm above the x-axis, below the x-axis, below the x-axis, which means increasing, decreasing, decreasing. Now I can write a justification because I've got my sign chart. I understand my sign chart. I can write a justification based on my sign chart now. So, for each of the points, determine whether G has a relative minimum, relative maximum, or neither at the point. Justify your answers. So I said there's horizontal tangents when, and I literally wrote this because if I'm ever, don't know, whenever it says explain, I want to write down everything I can think of that will justify what I've said. Horizontal tangents when G prime of x equals 0. I actually said when G prime of x equals f of x, which 0, I have a horizontal tangent. This happens at x equals 1, and I'm kind of paraphrasing here because I don't want to write all this on the board, but I literally wrote it out. Horizontal tangents, when that happens, at the points x equals -1 and x equals 1. G of x has a relative maximum at x equals -1 because the sign of the derivative from positive to negative at this point. G of x has a relative maximum at x equals -1 because the sign of G prime of x changes from positive to negative at this point. If you just wrote on your paper somewhere this, even without the f of x, you got a point. If you considered G prime of x equals 0, if you knew horizontal tangents happen when derivative equals 0, you got a point. One point there. A lot of you lost that point for not writing that, for not writing G prime of x equals. 1 point for x equals 1 and x equals -1, and then 1 point for your justification of your answer. All right. Part D. Between -4 and 3, which is where your graph, this was the hardest one to me because this was the most conceptual. Again, I bet you can't guess what I do. I do it for everything because it helps me remember. All right, so, and I do this, I go, okay, I know that this is the first derivative of f. So I'm looking at the derivative of what I have graphed. You want points of inflection. Points of inflection happen where what? I know it's where the second derivative equals 0.
So where is the like from counting up to counting down? Like how is
It is. Where is the slope of it's maxes and mins of the derivative. Maxes and mins of the derivative. Okay, that's why, and there is, and I got confused myself on this. This is, I literally, like, if you look at my work, and this was where I worked it out myself, I literally wrote this because I'm thinking through it. The second derivative of G is the same thing as the first derivative of F. So you're looking for points of inflection for the graph of G. And G is the derivative of F. Or G is, no.
G is F prime.
No. G prime is F. G, this would be the integral of F. This will be going backwards. So don't think about that one. Don't think about the relation, because what you're wanting to do, your sign chart, okay, your sign chart on the bottom is always going to be your first or your second derivative, and it's going to tell you about the function, okay? So this is G. Don't worry about how G relates to the graph. What we want to know, you have to know how the second derivative right now relates to the graph, okay? If you have a graph of the derivative, and you want to know where the second derivative equals 0. How do you find that? Well, if you've got a regular graph,
where is our only derivative? Or where the max and min are?
maxes and mins of the
So what
derivative.
about on the original graph?
What?
On the original
She's
graph.
confusing me, Sana. Okay.
So where would this G prime prime be on the original graph?
That would be the derivative of this graph. Okay. This is why this is confusing, because they're using these different variables to understand. So if I can relate it back to the original variable, okay, that's there. So the second derivative, right, F is. So that graph that you're given, okay, F of X is the same thing as G prime of X. So the graph that you're looking at a first derivative graph, is what you're looking at.
Of G prime.
Of G.
Okay, first derivative, but it's the normal F.
Correct. But they're not asking me any questions about f, they're only asking me about g, which is why it gets confusing, right? So essentially they're giving you all that and you're having to interpret a first derivative graph for all of this. So now, one derivative up, if you want to know where it equals, that one derivative up equals 0, you're looking for maxes and mins, right? If I gave you a regular graph, let's say this graph, and I said, where is the derivative equals 0?
Where does the derivative?
At the maxes and mins, right? Where is the slope 0? If this graph is a first derivative, then define where the second derivative equals 0.
Okay, wait. What graph is that supposed to be?
That's just a random, I'm just saying, for example.
Like, let's say that's like, it's the graph that's like, that's the normal graph? Okay.
This is just a normal graph.
So if we graph the derivative, so, okay, I just don't understand.
Okay,
I don't understand G prime prime.
if I give you just a graph and I say, where is the first derivative 0? What would you tell me? Because derivative is slope, right? Are you with me? So, right. So now I'm asking you, where is the second derivative 0? Okay. But really, based on the graph that I have, what I'm really asking you is, where is the first derivative 0? So it's the same thing. If you can understand that you're already looking at a first derivative in this situation, and they will get you are, I mean, you are guaranteed you're going to have one of these where they give you a graph of a derivative like this.
But if they gave us the original graph like that one,
It would be points of inflection, yes.
Yeah.
Yes.
But they're not going to give us like that.
Right, they will give you the derivative graph, and you'll have to understand that it's the derivative graph that's given. So what is the answer? Well, if you look at your graph here, I don't even have the right stinking problem up anymore. Where is the derivative 0? And that's what Dylan said earlier. Well, it's the maxes and mins, right? So at the top here, at the bottom of this circle, there's one other little place at 1. So it looks to me like that is happening at, again with my sign charts, at -2, at 0, and at 1. Remember, I'm cut off here and here. Remember, we're looking at slope. So from -4 to -2, what's the slope look like? Positive. So that means I'm concave up. From -2 to 0, down. From 0 to 1, and from 1 to 3. Therefore, g of x has points of inflection at x equals -2, x equals 0, and x equals 1. Because the sign of the second derivative changes at these points. You don't have to say it goes from positive to negative or negative to positive because it doesn't matter. It doesn't ask you a certain concavity. It just says, where does it change concavity? Surprisingly enough, this was only 2 points. You had to say, you could say the sign of, this is what I did, changes.
So, we get back to
I just said there's a sign change on the graph. I didn't say of.
You have to say at those points.
Yeah, I did say at those points.
Yeah.
I didn't say. I said all the graph is at. I didn't say that there's sign changes.
You have to say, yeah, you got to say because that's what they call the second derivative test. So they're making sure you understand the definition of the second derivative test.
So I'm looking at this graph of F. So this is the graph of the of parent F. Right?
Okay, yes, but F is the same thing as G prime of X. Because look how it's defined in your problem. It says that G of X equals the integral from 1 to x of f of t dt. And anytime you see that, you know that means that the derivative of g is equal to f. They are using the fundamental theorem there to do that. So they're double testing your knowledge.
So can I go about it as a regular problem, like find the derivative of like when you put max and then that's what you have your
Yes. But you're finding, when you find that, you're finding the horizontal tangents of the first derivative, which would be where the second derivative equals 0. If you need the first derivative equal to 0, all you have to do is find where it crosses the x-axis on here, because that is the first derivative. It gets quite confusing. There's a lot, yeah. All right, let's run through number 4, and then we'll probably stop. We'll do 5 and 6 and the rest of the multiple choice that we didn't get to last week tomorrow. And if you don't need it, you most certainly may use your workday tomorrow to work through, but if you feel like that would help you to listen to that, you may do that as well. All right, the function. Did y'all hear all that? Is it? No, there's not. They'd be a lot louder than that. Do what? Oh gosh. His nostrils were flared all in. I didn't have anywhere else to put him.
And you were like,
All right, number 4, and then I'll be done. I promise. I know that this is a lot, but such is the AP exam. I feel like it might be coming from below, not up the side. All right, number 4. The function f is defined by. Now, I was a little lenient in how I graded this one for y'all, but I did want to talk about something here. I wanted to make sure I talked about the dx's and dy's and dt's and all of that, but here's something else that I wanted to talk to you about. Most all of you got the derivative here. You remembered the chain rule. I was super happy. And so whenever you did it, you ended up with negative x over the square root of 25, 25 minus x squared. And of course, that's coming in that 2x and that 1/2 canceled each other out. But you have to put this restriction back on it in order to count. Okay? Because it's initially defined and it still impacts the function. I did not do it either. I would have lost my point. Okay? So this was actually 2 points, surprisingly. I thought it was a very easy 2 points for you to have. Just looked at chain rule. That's all they wanted to see there. But remember, if you don't include, I'm going to assume they would probably give you one of the 2 there if you didn't include the restriction. I gave it to you, yeah.
I forgot when I did the chain rule, I was called back 2x instead of negative 2x. So I messed up everything.
I got you.
So you had to
Negative 3/4 on that.
I got you.
So do I not get the point here? Because I didn't cancel those out. It's still right. Because I kept the 2 over there as well. I didn't like cancel one of them out and leave the other.
No, I'll give you that. I'll give you that point. I didn't see the 2 up top. All right, part B. Write an equation for the line tangent to the graph of f at -3. You thought this was hard? So, yes, you could do point slope. So, f prime of -3, so if I plug that in, I get positive 3 over the square root of 25 minus 9, which is 3 over square root of 16, which is 3 over 4, and that is my slope. right? I still need a point. I know we've done these till we were blue in the face. If I find f of negative 3, because I do need a point itself, and remember this is non-calculator, so I'll just run through it real quick. Square root of 16, which is 4. So you have the point, negative 3, 4. You have the slope, 3/4. So y minus 4 equals 3/4 times x plus 3. And for whatever reason they like it solved for y, so just move that 4 over there. You don't have to do anything else with it. So you got 1 point for finding the correct slope.
Wait, I found the slope.
I didn't give you your point?
Yeah.
Okay, I'll fix it. Put a note on the front.
But I didn't put the slope in my equation, but it's on here where I found it.
But if you found, you literally, f prime of negative 3,
I do not know why I didn't put it in my equation.
you get a point. So I will definitely give you your point. Put a note on the front.
I put negative 1/4 in my equation and literally found 3/4.
Part C. Most of you knew what to do for part C, but you didn't understand how to do it. Calculus C. Well, they were looking for, because it said, use the definition of continuity. That was the key. What does that mean? Tell me what it means to be continuous. Limit. The limit as x approaches the number from the left of g of x has to equal the limit as x approaches 3 from the right of g of x, and it has to equal, so that there's not the hole plugged up here somewhere, it has to also equal that. So you had to say this, and you had to show it. What is this? The limit is x approaches 3 from the left of g of x. Well, I need to know that that means I need to use the f of x equation. So that means that it is, whatever that comes out to be, what is it, 3 or 4? Yeah, they all come out to be 4. And then the limit from the right of g of x, I have to use that x plus 7 equation. And then, oh, it's negative 3, sorry, y'all. Wondering why that one come out. And then g of negative 3, of course, I use the same equation, right? So you had to, so here, if you considered the one-sided limits, you got a point. And if you answered correctly, so which is again with the limits, so they were big on the limits there, it was 2 points. And your answer, the answer here is therefore. G is continuous at x equals negative 3. So, because the limit as I approach from left equals the limit. This was a straight definition problem. That's all this was. This was a 2 point. One was the one-sided limit, and one was saying that you had to say the limits with both. But it is continuous. Why are you saying no?
Yes, I said yes. Yeah. I said yes, but no concept. Yeah, I said yes.
I said
Like didn't get.
It said the 1 point is answer with explanation.
Yes. I said because there's no continuity.
But this is your explanation. That's why I say it's really a double-sided.
I put explanation.
I literally said it equals. But your explanation had to include the definition of continuity, because that's what it is. Yes.
There's no discontinuity where you that works.
Yeah.
So I got the point for the limit, but the other point, what were they looking for? So I'll say continue because there's just a limit on both sides to make it 3.
They're playing Kahoot right now and making problematic.
What?
Find the value. This was a U sub. I enjoyed this problem. Thank you, Dylan. What? If I let u be 25 minus x squared, du would be negative 2x dx. So this is the integral from 0 to 5. I need a -2, right? So I counter that with a -1/2 out here. And I have u to the 1/2 du. But you cannot forget to adjust your bounds. So u of 5 is 0. And u of 0 is 25. So this becomes 25 and this becomes 0. No. Say that backwards. This becomes 0. This becomes 25. So again, I have to reverse and negate. So this is 1/2 from 0 to 25. U to the 1/2 du. You got to evaluate. It says find the value, so you need a specific value.
No, I mean, can you leave it with the other? And then plug it in?
Yes, and then plug in. Yes, as long as you go back and plug in. I had to change the bounds with respect to you. Zero to 25. Now, if you didn't change the bounds here, that's okay, Dylan, if you didn't change the bounds. But what's going to happen is here, you would need to plug this back in for your u before you evaluate. 125 over 3. So let's see, 1/2 times 2/3 times, not 125, 25 to the 3 over 2, and then of course minus the 0. If that base is 0, that's just going to be 0. Okay, so I get 1/3 times the square root of 25 is 5, and 5 to the 3rd is 125. I left it there. 2 points. You got 2 whole points for finding the antiderivative correctly. Then you got 1 point for the answer. So here, 1 point. If you can't find the derivative, the antiderivative, that's always my first go is u sub. I was surprised nobody thought that was some type of inverse trig function or anything. I would have tried that.